In this next video, I want to talk you through the Kruskal Wallis test, what it is, when you would use it, and how to perform it in R. So the Kruskal Wallis test is very similar to the one-way ANOVA. Essentially, it's the non-parametric version of it. What we know about non-parametric stats is that they test the medians rather than the means, so are a bit more resilient against skewed data or where there's lots of outliers. Similar to the one-way ANOVA, the Kruskal Wallis test compares medians rather than means among groups defined by the categorical variable for more than 2 treatments. So remember, ANOVA, Kruskal Wallis, always more than 2 treatments. If it's 2 treatments or less, you should be thinking t-test and Mann-Whitney U-test. As I say here, it's the non-parametric version, but similar to with the one-way, it's testing against the medians this time, how far away the median values are of the different categorical variables. So have a think about the assumptions. So we normally use a non-parametric if the data doesn't normally follow a normally distributed data set. You could try and transform it, you might try and log transform it, but if it still doesn't approximate a normal distribution, we would proceed with a Kruskal Wallis test. An example of this might be testing the difference in crop yield with 3 different fertilizers. So let's have a quick look at how you would do this in R. So in R, I'm already in my ANOVA working directory. I'm just going to read in dataset. I've called it Kruskal, and there's weight and treatment. So if I just open this and have a look, you can see you've got weight of the different crops under 3 different treatments: nitrogen, potassium, and phosphorus. So remember, one of the assumptions for an ANOVA is that the dataset approximately follows a normal distribution. So I'm just going to check this by running subsetting and have a look at nitrogen, potassium, and phosphorus. I'm just going to plot those out to have a look at their distributions. So looking at nitrogen, looking at weight, we can see that although it's got this big rise here, it doesn't really follow a normal distribution. Potassium, definitely not, and phosphorus, definitely not either. So you could log transform them, square root transform them just to see, and then use a parametric version of the test. We're not going to do that. We're going to proceed with a Kruskal Wallis test. And again, similar to the code that you'd use for one-way ANOVA, we're using that weight against treatment, so response on the left-hand side of the tilde, and then our predictor on the right-hand side. We're telling it we're using that Kruskal data set, and we're using that function Kruskal test. We're going to run this, and bear in mind we're not using that linear model, that LM function here, so we'll run that. And it's giving us a rank sum test, and the data it's used is weight, and it's looked at that by treatment. So the Kruskal Wallis chi-square, you can report it as chi-square. Normally this is reported as a H value. We've got that value, we've got our degrees of freedom, and we've got our p-value, so 0.06. And what you can do is actually, in base R, there's no way that you could do the multiple comparisons like we did with the one-way ANOVA. There is this package called nparcomp. So I've already installed it. I'm just going to call it into this session. So if I run that, it's loading, and you can see that that's loaded in OK. How we're going to do that is I'm just going to call it crop. I'm going to create something called crop. I'm going to use that nparcomp function, and I'm just going to feed it exactly what I fed it when I was doing that Kruskal.test. So weight being predicted by treatment, and that's the data. So we can run that. And we can just use a summary of that to have a look. So you could do this all in one line of code if you want. I've just split it up. So having a look at the summary of the crop, you can see here that the p-value of nitrogen against phosphorus is significant. Nitrogen against potassium is significant, but not between phosphorus and potassium. That's just one way that you can look at multiple comparisons on a non-parametric test. So that was the Kruskal Wallis test.